Hey guys, we're going to do lesson 12.3 notes, and this time we're going to do surface area of pyramids and cones. And so in 12.2 we did prisms and cylinders. It looks very similar to what we did, but instead of having two congruent sides, opposite sides, it's going to have a base and then it's going to come up to a point. And so you can see that in this first drawing here, we've got a base, and that's, let's say, a square. In all of these cases, the bases are going to be regular polygons, which means all sides are going to be congruent. And then we have a vertex, which comes up to a point. And we want to find the surface area. So actually, if we take this particular pyramid and we open it all up, okay, we'll have a square. And then because the sides are all the same on our square, all of these triangles will be the same size. So we can find the area of the square, and then we could add the area of the four triangles. 4 times the area of the triangles. We could do that. We can do that for any of these pyramids. We can take the base and then add the area of the sides, which are always going to be triangles here. So how do we find surface area of a regular pyramid? Well, like I said, we've got our base, which is a square. And then we have a bunch of congruent, if I can get a highlighter here, congruent triangles. So we've got one triangle here. Since the base is a square, we're going to have 4 of those. So we could do each one independently, like I showed you on the previous page, but we could do it a little bit quicker by, since are all triangles, and the area of the triangle is 1/2 base times height, instead of doing the base for each one, since they're all the same, we could do the perimeter of the base times height. And so that's what we're going to use. Now that when we're talking about height, that's the height of the triangle. And the height of the triangle, to differentiate it from the height of the actual pyramid, they're going to give it an L, which is called the slant height. That's also the height of the triangle itself. And so here's my formula. Again, this first part here is based on the fact that we have a triangle, which is 1/2 base times height. So we have 1/2 times the perimeter, which is all the base lengths, times the slant height, which is the height of just the triangle. Okay, so we have a figure here. I want the surface area of the square pyramid. Surface area is 1/2 the perimeter times the slant height plus the area of the base. The base for this figure is a square, okay, because it's going to be a regular polygon. It's this guy right here. And we see that it has sides 12, which means that the perimeter all the way around is 4 times 12, which is 48 centimeters. Then we also want the slant height. So the slant height, that's L, it comes from the length of the side of a triangular side. So we have the height of our pyramid, which is 16. We don't know the slant height yet, but I do know the length. Right, so I have this right triangle, and I'm just going to make a kind of pull that triangle out here. So I don't know what the slant height is. That's the height of my triangular side of my pyramid. The height of the pyramid itself, the whole thing, is 16. And then this is from the center to the side, and so that's actually halfway across the square, so that's going to be 6 centimeters. Now I have some sides where I can find L, and I'm going to take 16 squared plus 6 squared equals L squared. So 16 squared is 256 plus 36 is equal to L squared. Get my handy dandy calculator. 256 plus 36 is 292. And then of course we got to come back and take the square root of both sides. And the square root of 292, that's about 17. I'm going to go out to the hundredths place because this isn't my final answer and I want to try to keep it as correct as possible. So I'm going to go 17.09 is how much my slant height is. Centimeters. And then the area of my base, well, my base is a square. So if I do length times width or base times height of the square, that's 12 times 12, which is 144 centimeters squared. Okay, now I'm ready to put it all in the equation and see what we get. So the surface area is 1/2 the perimeter, which is 48 centimeters, times the slant height, which is 17.09 centimeters, plus the area of the base, which is 144 centimeters squared. Change up the color here just a little bit so you can see it. So I'm going to take 0.5, which is 1/2, times 48 times 17.09, which is 410.16. And then this was 144, not 14, plus 144 is equal to 554.16, but we want to round it to the nearest tenth. So it's about 554.2 centimeters squared. Okay, so I had to find that slant height on there. Let's just go back a little bit to this picture, just really quickly, and I want to make sure that we understand what we're doing. So we have, here's the slant height. Remember, that's just the height of the triangular sides. And then, of course, perimeter is our distance around. And so that we go all the way around for that and just add up the sides. There's our perimeter. And then we do the area of the base. Okay, number 3, we've got another pyramid. This time it is a hexagonal pyramid. Okay, so we've got a hexagon for the base. And we're still going to use that surface area formula. Surface area is 1/2 the perimeter times the slant height. That is going to get all of the triangles around the pyramid, plus the area of the base. So we want to do the perimeter. Well, this is a regular hexagon, which means that all of the sides have the same length. And in this case, each one has 5 centimeters. So a hexagon has 6 sides. We're going to take 6 times 5 centimeters, which is 30 centimeters. The slant height is, it's given over here, it's the length or the height of one side or one of those triangles, which was 8 centimeters. And then we have the area of the base. Now this is where it gets a little bit trickier, so I'm going to draw in a hexagon. We'll see if I can get one here. Okay, it's a regular hexagon, so I'm trying to make them all the same size. And then it's going to have a center point. And I should be able to then break up this into 6 triangles, right? And they're all congruent triangles. Well, I know the base is 5 centimeters, and they gave me, this is actually the height of one of those triangles. That's from the center. Oh, that's from the center to the edge here. So if we are just focused on one of those triangles right here, this height is 2 centimeters. Okay, so I'm going to find the area of one of those triangles. The area of one is 1/2 base times height. So I'm going to take 6 times the area, which is 1/2 times 5 times 2. That's going to be 30 centimeters squared. Okay, now I'm ready to fill in my surface area formula. So surface area, it was 1/2 the perimeter times the slant height. So the perimeter was 30 centimeters. The slant height is 8 centimeters, and then plus the area of the base, which is 30 centimeters squared. So we've got to do all of this first. 1/2 times 30 times 8 is 120 centimeters squared, plus 30 centimeters squared gives us 150 centimeters squared for the surface area of that hexagonal pyramid. Okay, surface area of a cone. Very similar, it's just that the base is a circle, and of course we have specific formulas for a circle. So we have surface area, remember, is 1/2 perimeter times slant height plus the area of the base. Well, the perimeter is actually circumference. Remember, circumference is pi times diameter. So I've got pi times diameter for my circumference, and then the slant height, plus the area of the base, which is pi r squared. Now, what they've done in their formula is they simplified that because half the diameter is the radius. So they said, well, that's really simplifies to pi times r times the slant height plus pi r squared. So that's where that comes from. And there's our formula. Okay, so we have a, it says the conical slate roof at the right has a height of 16 feet and a radius